Hi guys, today we're going to learn about evaluating investigations. And this is a very important topic that scientists deal with in order to make their experiments valid ones. Hence, through your experiment or investigation, you should be constantly evaluating. Actually, you should be constantly evaluating the method, the results, the materials that you're using. So usually scientists, they do evaluate in order to improve their work, to improve the results that they are getting. So let me give you an example. The automobile test engineer must know the accuracy of the speedometer in order to express the fuel economy performance with confidence. So in this case, the engineer has to evaluate the accuracy of the speedometer. So he will confidently express the fuel economy performance, whether for the CEO or whether for the clients or the customers. Let's start listing our objectives for today. So we will start by evaluating experimental results and detecting errors. Also, we're going to identify anomalous points on a graph and suggest the cause of error. So we will learn how to evaluate the hypothesis and how to evaluate the method, and we're going to suggest some improvements. And finally, we will check the success criteria and we will practice together. Let's start now by evaluating the hypothesis. So, when we record the results of our experiment or we represent our results in a graph or in a table, or when you represent the data, you have to interpret the graph or the data that is collected. And finally, after interpreting the data or the graphs, you have to evaluate if your hypothesis was supported or not. While you are evaluating if your hypothesis was supported or not, when you're interpreting the data, you may find some results that are anomalous ones. So part of evaluating the hypothesis will be related to anomalous results. Obviously, I know that you're asking yourself, what do you mean by anomalous result? Anomalous result is a result that doesn't fit with the pattern of the other results. So let's look at these two graphs. So these two graphs, they do represent different results for different experiments. So let's look at the first one. So this point represents an anomaly. Why? Because it's so weird compared to the pattern of results that we are recording after, or we are recording during the experiment. And this one the same. So this point is also very weird compared to the pattern of points that were recorded during a given experiments too. So these points, we consider them anomalies, and there are certain causes for these anomalies, and we will explain about them later during this session. Just let me give you a hint. You can't prove your hypothesis whether it's correct or not. What we can do is that we can support our hypothesis. So we have to refer to the table that is including our data or to the graph that is presenting our data to help us support our hypothesis. So briefly, while you're evaluating your hypothesis, you will check whether the results support your hypothesis or not, and you will evaluate the anomalies, or you will check if they exist or not. Now, how can we evaluate the method? So, your method probably wasn't perfect. That's okay, as long as you can discuss the issues. So keep in your mind, we have two types of errors in your method. Some errors will be related to the reliability of the method, and the other errors will be related to the validity of the method. Now guys, let's explain what we mean by reliability of method. So if you are conducting a given experiment, okay, and you are repeating each and every time this experiment and you are getting the same result, this means that your experiment is reliable. If you are also repeating the experiment each and every time and you are getting the same results or the same measurements, this means that your measurements are also reliable. So, a measurement is reliable if you repeat it and get the same or similar answer over and over again. So, reliability refers to the consistency of a test in measuring the same thing each time. The first question that you have to ask about the method: did your method allow for a consistent set of data to be collected? So, were all the points collected following the same pattern? Or did you notice a point that is not fitting with the pattern of the points that were collected? This deviating point, we call it anomalous result. So again, this is one example of an anomalous result that was obtained while we were conducting the given experiment that is represented, or where its results were represented by this graph. So as you see, this point seems to be a strange one and deviating away from the other points. Okay? Now, how to test reliability of a measurement? Let me remind you that I defined reliability as it refers to the consistency of a test in measuring the same thing each and every time. So, simply, how to test reliability? We can test reliability by repeating the experiment each and every time. So, when we repeat the experiment, we have each and every time to write the given measurements or the given results, and we will compare the values. So, the more similar repeated measurements are, the more reliable the results. So, you can test reliability of the experiments through repetition of the entire experiment and looking for differences in the final results. So, the more similar repeated measurements are, the more reliable the results. However, repetition doesn't make your result reliable. It just allows you to check whether or not they are reliable. So you can't use the repetition as a given protocol in order to prove the reliability of your method. So repetition allows you to check whether your results were reliable or not. So reliability, as we mentioned before, is not proved or improved by repetition, but through the design of the experiment. So you can, for example, fix the variables, and also keep in your mind that sometimes using poor tools to measure also will affect the reliability. So instead of using the beaker to measure the volume, you have to measure the volume using the measuring cylinder. Or instead of counting loud, you have to use the stopwatch, which is more reliable to measure time. Now, how to improve reliability of an experiment then? This is done by increasing the reliability of a single measurement, increase the number of repetitions per measurement, use averaging such as line of best fit. So we have to ignore the anomalous points. So we will use two examples to clarify more what do we mean by reliability. So suppose that you measure the temperature of a liquid sample several times under identical conditions. The thermometer displays the same temperature every time. So we are repeating the experiment and we are recording the same results every time. This means that the results are reliable. So simple. Now, let's move to the other example. A doctor uses a symptom questionnaire to diagnose a patient with a long-term medical condition. Several doctors use the same questionnaire with the same patient but give different diagnoses. This indicates that the questionnaire has low reliability. Why? Because each and every time we were having different diagnoses. Even though we are studying the case of the same patient using the same questionnaire. So we can indicate that, or we can figure out that the questionnaire has low reliability as a measure of the condition. As if you are using the same experiment each and every time, but you are obtaining different results. So you can say that your experiment is not reliable. And in this case, the questionnaire was not reliable to be used to measure a given condition. So, in short, two people measuring the same variable differently is an issue with reliability. So, previously we were explaining about the first type of errors related to the reliability of method. Now we're going to explain about the second type of errors related to the validity of method. So, validity relates to the experimental method and how appropriate it is in addressing the aim of the experiment. So, while you are doing a given experiment, you have to think, is my experiment suitable? Does it test what it's meant to test? Am I actually measuring what I want to measure? Then, we have to learn how to test validity. Several aspects contribute to the validity of the experiment: the equipment, the method, and the analysis of results. So, identifying the proper variables is the cornerstone process to start conducting your experiments. Make sure your variables are actually the correct ones to assess what you're trying to investigate. For example, if you are interested in health, then you have to think, is measuring someone's weight the most valid measurement? Or I have to use the BMI, for example, or I have to measure the pulse rate. So you have to choose proper variables according to the experiment that you want to conduct. So another point that you have to keep your eye on is that to make sure that the controlled variables are actually not affecting the dependent variable you're trying to investigate. So, as an example, if you're investigating the speed at which a different salts dissolve in water, make sure the temperature of the room is the same for all tests, because as you know that temperature is one of the factors that affect the solubility of salts also. So if the temperature of different beakers was different, this means that your results will not be valid results. Proper tools also play an important role in the validity of an experiment. So make sure your measurement tool is the proper way to measure your variable. For example, if you want to measure the change in the acidity, you know that if you want to measure the change in the acidity, we have to monitor what do we call the pH. Then the blue-red litmus paper will not give you a valid set of data, but you may need a pH probe, which means that using the litmus paper will not give you the measurements that will allow you to monitor the change in the acidity, but using the pH probe will allow you to monitor such a change in acidity. So as you see here, this is the blue-red litmus paper. So it will just show you that if it turns blue, this means that it's touching the base, while if it is turning red, this means that it's touching an acid, while the pH probe is going to give you the exact measurement of the pH of a given solution. So this is to say that you have to use the proper tool to measure your variable. Let's deal with more examples so you will understand more about validity. The first example: the thermometer that you use to test the sample gives reliable results. Why? Because when you were repeating the experiment, you were getting the same readings each and every time. However, the thermometer has not been calibrated properly, so the result is 2 degrees lower than the true value. Therefore, the measurement is not valid. So even if the given measurements or the given results, they were reliable, they may not be valid ones. You may face, for example, that a given thermometer shows different temperatures each time, even though you have carefully controlled conditions to ensure the sample's temperature stays the same. The thermometer is probably malfunctioning and therefore its measurements are not valid also. Another example also, if a symptom questionnaire results in a reliable diagnosis when answered at different times and with different doctors, this indicates that it has high validity as a measurement of medical condition. So now, because we have identified the areas of reliability and validity that need improvement, so you have to suggest specific ways to improve on these. So your suggestions must be specific. So I'm not going to accept any of your suggestions to be try harder or do more. This is not accepted. Your suggestions also should be realistic, and you have or you may need to do a bit of research to find suggestions too. So also I don't know is not accepted. So after all this explanation, I want you just to check the success criteria. So you have to be able to evaluate the validity of a hypothesis based on the outcome of the scientific investigation. You should be able to evaluate the validity of the method, and you should be able also to explain improvements to the method too. Let's practice together, guys. Go to the Edmodo page and respond to the questions of the worksheet posted there. Don't forget to join the Zoom class at the given time assigned by your teacher. Thank you.